All right, today we're going to be talking about WebViews and custom tabs. So let's just go ahead and jump into it because if I take too long, this is going to be a long video and it's a lot of talking, not a lot of screenshots. So first, let's just talk about what a WebView is. It'll look like this. It's basically, you can imagine it as opening kind of like a mini browser in your phone or in your, app, right? These used to be, in the past, a lot less secure. These are typically used when a website is embedded into an application, right? As you can see, especially when there's a lot of crossover between the website's JavaScript code and the JavaScript, or not JavaScript, the Java application code. The JavaScript interface in WebViews actually used to be like regarded as really insecure, and you could even achieve full Java code execution. But this is no longer, this hasn't been an issue in modern Android for a while. So if you see people harping on about it, maybe tell them to read the release notes or maybe use a newer API version, past Android 10 or 11. For custom tabs, we'll talk about those later as we get into it kind of towards the end. But we'll kind of examine these a little bit from a developer perspective, right? So these web views are basically UI elements, or at least you treat them like UI elements. So you add a spot in your activity main XML file, and then you need to use like the find view by ID in order to render it onto the screen like it is here. And then also, if you're in order for this to actually work, your app needs to have internet permissions, which sounds obvious. But this is like a small embedded browser that you can interact with most ways you would, like Chrome or Google or whatever app you use as a browser on your mobile device. The interesting thing is that if you're running the emulator in Android Studio, at least, you can use whatever browser you've got on your host operating system, and you can actually debug these little windows. It'll come in handy. Now, of course, for us as either developer or a pen tester, it's useful when most apps that you'll find in the Google Play Store are built in release mode, so they'll have set web contents debugging set to false. But some apps will intentionally enable it regardless, so it's always worth it to check. Many mobile apps are, following on this, a lot of mobile apps are completely developed around web views. You can see this in frameworks like Cordova, where they're designed basically to map web development onto, Java Android app development. And apps that are basically a web view will have a main activity that just loads a URL, and then the native code will be related to the framework that those developers use. Therefore, right, most of the logic will be in the assets folder when you're decompiling. And so you should be able to find like relevant HTML, JS, CSS. Now you might think like, okay, well, even though you can load these, you can load these web views remotely, so why would I be using local files if we have, because we've already talked about secure storage, right? We know that holding onto files isn't necessarily the best thing to do, especially in versions of Android that don't have scope storage enabled. And that's a good observation, but there's still a little bit to be discussed because you can access local files and there is some legitimate use cases. So, think about when you want to stand, up a website from inside the app itself. If your app is built almost entirely around web views and your user has no internet connection, you don't want them to see this, right? Complete like, or I mean, this is a bad example, but you don't want them to get like a, can't reach this website error if, there's some functionality of your app that can be, localized, right? And at least, you want to show the user an error that relates to what they're experiencing. So in Android Studio, at least in my instance, right, if you create an assets directory, put an HTML file in there, here's how you can access it, right? And what you might think is like, okay, well, we're using a file URL here. Does this mean that, if we can parse in this load URL to another app, for example, would we be able to read arbitrary files within the, code, or at least within assets? And typically that would be the case. There's a few other things I want to touch on that are similar to that, but if we were to move, like, for example, the index HTML into the application directory, which you can't see very well in the screenshot because I so smartly covered it up, but you can see here it's in assets, and in this next screenshot, it's not in that folder. When we move this outside and we try to call it from like the data directory, you'll notice that you'll get like an access denied, right? We're not allowed to load that directly. However, you'll see this setting right here, set allow file access is false. If we were to set that to true, then you would be able to load files from the application storage. So that should answer that previous question of like, can we use a WebView to load or steal internal files? The answer is yes, but you need to have certain circumstances. There are some other permissions aside from just set allow file access. One is set allow content access, which lets you load content URIs. This is true by default, so keep an eye out for any content providers that are a part of the apps you're looking at. These two, for the purposes of just talking about local file access and nothing else, basically function the same. The only difference about the universal one, to my understanding, has to do with same origin policy and accessing these over the internet, which we'll talk about later, like I think on the next slide or in like 2 slides or something. But it should be noted that anything after API 30 or API level 30, these calls or these methods are since deprecated. And Android officially recommends to use asset loader instead of using this file provider, just because there's, again, like it's really easy to misconfigure this so that people can steal files from your WebView. So let's talk about another misconfiguration you might find, and that's JavaScript interface, like insecure settings. So this example, like, or one of the most powerful features of embedded WebViews is that you can make a bridge between JavaScript that's running in the WebView itself and the application. So you can see here these JavaScript interfaces. These kind of act as a bridge, right, between the WebView and the app itself. So these are how they're kind of communicating. In this case, right, these two things act as like the two like methods that are being run. And I think if we look at the next slide here, you can see these are the two buttons that actually call like this hextree.toast demo, this hextree.success function. Of course, it puts in false because it doesn't want to give us the flag that early. But you can also see, you know, here in this case, there's a few insecure things going on. The first one is that we can, you know, manipulate the URL, and that might be intentional functionality. Otherwise, it's just loading that HTML file that we just looked at, you know, that's on this slide here. But the other thing is that you can see that because we can supply an arbitrary, you know, URL that's going to be loaded as a web view, you can see that it sets JavaScript enabled, and you can see that it adds the JavaScript interface for this hex tree method here for us to look at, or what's the right word? Yeah, it allows us to interact correctly with this. So I believe all we need to do to actually get this working, I don't even have the HTML here because it's pretty straightforward. All you need to do is call like the hextree.success method. So just host some test HTML file that has like, you know, the script tag and that one function that gets executed, like on click if you have a button, or on load if you want to do it even faster. And then just send that URL, you know, this intent URL to the target app, and then you're good to go. Not super complicated, pretty straightforward. The next one we can talk about is cross-site scripting inside of WebViews, because, you know, it's a browser, HTML files that are being loaded. You could feasibly, you know, get some, you know, JavaScript execution going on. So here you can see they've got their JavaScript bridge, right, that's connecting with this success method. So we should be able to call, let's see, I don't know if they have the name here, but I'm assuming it's like hextree.success or something similar to that, like it was for the last one. But you can see how we can then again input this intent for the name variable, or this, you know, string intent extra name, and we can add some content to it. And then you should be able to see, I'm not sure which line it was on. Yeah, you can see that string, or at least that string gets parsed from somewhere. It gets passed into this init app or into this evaluate JavaScript function for this JSON object .toString. It gets printed out, right? So because we can control the input that's going in here with this name thing, if it's not being sanitized correctly, which you might think that JavaScript .toString or JSON object is sanitizing it, it's more just reformatting it. So it'll just be a game of like how much, fiddling you have to do with your payload. The one I ended up going with was this image source X on error alert. That one seemed to work fine for me. So that, you just supply this and then it pastes this into this HTML right here where it says object name. Just completely ignores the B tags. We're inside of script tags, so it has no issue executing just fine. And then, it calls the method that we needed to call. Pretty straightforward. Again, not even really worth, or we don't even need to show HTML in this example because it's just not really worth the effort. The next one we're going to talk about, we're going to touch back on some of these permissions again, and it's the same origin policy. So obviously, right, WebViews render websites, so we have to think about other client-side browser exploits. One to take note of is the same origin policy. We've covered this briefly in a blog post in the past when we were studying Burp Suite stuff, or like more generic web app stuff. But to summarize this, the same origin policy restricts how a document or script that's loaded by an origin A can interact with some resource from origin B. The question is, do WebViews behave the same way? And to answer that question, we need to talk about these functions again, which we talked about like 5 slides ago. But at least, with their with how they, fall in line with respect to the same origin policy. So set allow content access enables or disables content URL access within a WebView. That makes sense. Set allow file access. It's enabled or disabled whether or not, or checks whether or not the file has access within a WebView. This one, set allow from file URLs, it sets whether the cross-origin requests in the context of a file scheme URL should be allowed to access the content from another file scheme URL. So it's a little complicated, but if you have a file scheme URL like this, file Android assets secret.html, that's what this is referring to. The universal one is this direct or universal, meaning it's the this determines whether or not cross-origin requests in the context of this URL should be allowed from any origin instead of just the origins that relate to these other scheme URLs. This app here on the right-hand side is from the Hextree course, and they've got a really interesting GitHub repository that'll explain this way better than I can verbally. We'll have tons of examples. And you can totally use this for some bug bounty stuff if you just mess with it, like what, origins it's loading and stuff like that. So at the top of the activity here, you can see this current website. So this is displayed using window.location.origin. This shows us what the browser is considering the origin of this page. Next, you can see that the page embeds these 5 different iframes. 2 of these are websites. And then the other ones, there's a full path to a file. There's a local file here that's in the assets, scheme. And then there's this one here that's from a content provider. So already we can see which origins can be loaded into an iframe. At the very least, and that's, that first one isn't interesting. That should be just if you have, the only one that isn't available is in here is this full file path. This is the only one that shows you like the web page failed to load. And that's because that requires you to have allow file access. But of course, if we have allow content access, you can access the content provider, you can access these schemes. It's not a huge deal. The interesting thing here is these lines after this first one about whether or not you can just load in the iframe. The second one will try to perform iframe.content document, which on some versions of WebView or like whatever your WebView client is, this might not work, like it is in this screenshot for me. But it'll try and read out the content of the document in the iframe and then show it. The second one is fetch the URL, so it'll try and read the data just by calling the fetch method. And then this other one is a XHR, XML HTTP request. It's similar to fetch, but there's a few key differences, especially in the edge case behaviors that you exploit in this course. So for example, if we're accessing a file URL and allow file access from file URLs is set to true, we would have access to files through an XHR request, which we can't see in this screenshot. This is kind of a bad example. But if we can, what that tells us is right. If as long as we can use an XHR request to interact with one of these, with an origin, then it kind of lets you bypass some of those same origin policies. So like if we inject malicious JavaScript into a file URI, or we can somehow load that file directly like it is in number 4, we could steal the contents of any like accessible files in the app directory. But the real question is, right, like how do we do that? There's more than one way to do it. I used that's from the GitHub where you'll download this app from the Hextree course. I use the extract native libs trick, where basically what you need to do is you make this resources directory, make this other directory relative to your architecture of your emulator, and then add an HTML file here. And then what you're going to do is you're going to build the APK and sign it. You're going to build it in debug mode so that it kind of preserves this file structure. Make sure that in your like application, you have extract native libs set to true. And then what's going to happen is another application could then call, this, we could then use this malicious HTML and load it in a WebView because it's accessible locally and it doesn't freak out the same origin policy. The challenge that's related to this task has to do with what this, JavaScript is doing. So you can see we're getting the token file context, and within 5 seconds, the token will be removed, which is why this automatically then takes that token and runs the auth callback request after it, uses the XHR request to open it and grab it. So again, there's another way to do this that's a little bit more elegant that has you, let me see if I can find it here. There's another way you can do this where you take advantage of the content provider, where you can basically stick up your own website inside of the content provider that you're pushing. And then you have the target application open a web view that's in your content URI, and then it should be able to get around the restrictions on the iframe being rendered. But I couldn't get that working for a demo. So this is as close as I kind of got. Again, here's kind of how that would work. We're getting the file path from the native library directory, creating this malicious file path, right? And then we're sending that over to the target application in an intent with this URL parameter. Again, most of the logic of actually getting it is here, but the important part here is understanding like the native libs trick and how that's getting around the same origin policy. Google acknowledged, by the way, that this like strategy, the same origin policy, not like bypass, but definitely like strange behavior related to certain combinations of permissions being enabled or disabled. Google acknowledged that it was strange, but they didn't really classify it as a security vulnerability or like a bug. I mean, it's not a bug technically, but it's definitely something you should try to be cognizant of if you're being limited by some same origin policy during a pen test. Now we can talk about what I think is a little more interesting, maybe a little bit more relevant, is custom tabs. So these are different from WebViews despite looking the same and acting similar, at least from the user layout, right? And it opens up a mini browser in your application. Sounds a lot like WebViews, but there is a key difference, and that's that custom tabs are not UI elements. These are basically, this is opening like Chromium inside of your app, basically. So think of it as a mini browser, not in the same way you think about WebViews, because WebViews are UI elements. They have file access. They have a few other accesses that custom tabs just straight up don't have. In this example here, I think I'm using a slightly newer version of the Android API, and I'm using the Chromium browser, which I had to just manually install the APK for, but that is what I saw the most consistent results with. And most of the time in your test case, right, you want to use a common browser like Chrome if you can, but I wanted to disable Google APIs without jailbreaking, so there was or not have to jailbreak a Google API emulator. So this is what I ended up doing. If you look at the custom tabs intent.java file, you'll be able to see that like the launch URL method that we can see like right here is basically, it uses that intent and some extra data that gets put through a start activity method. So where the activity is, just being started in the browser, you have configured to handle custom tabs. So it's important because custom tabs were originally launched by Chrome because, it's part of the browser itself, right? And then they were kind of, launched as a part of the app or something that can integrate with it. So this difference between, WebViews and custom tabs naturally affects how you ought to think about their attack surface. Generally, you could say that custom tabs are safer because the tab can't access file providers, content providers, or files that are owned by the app. And for that reason, Google typically recommends these over WebViews. But even though that apps can expose like native Java methods through custom tabs, apps can still set up like post message communication that you can exploit depending on the context. And custom tabs are also, they have the ability to verify origins. So, and that'll give the app that's calling that's loading that website a few more permissions. So let's say that you have like a special authentication header. You could restrict that header to only be used by apps that are validated. So you would, on your website that's going to be loaded, have this right here, which is a digital asset link. And what this does is say, hey, if this is your package name and you're in this namespace and you have a fingerprint that matches this, the APK sign and the fingerprint matches this, then I'll give you permissions, or you'll have a verified origin. And what that typically means is you get some extra functionalities. One of those functionalities is being able to add additional headers to requests that are going to the browser in the custom tab. The other functionality that we're going to mess with is the ability to communicate using a post message. And typically that's only after you verify, but it's not required to verify to have post message. So let's see here. Yeah, so this example is I guess this is a bad screenshot, but this opens a custom tab inside the application, and then we're just debugging it right here. So even though this this custom tab is being opened by the application, right, this is another website. So this logic here, this JavaScript that's a part of the website, gives us a little bit of insight on how it establishes a connection with the app and how it communicates back and forth. So you can see that it registers an event listener for message. It establishes a port or like a channel to communicate over. And then when the application sends this init data to it, it'll then, send this init complete. And then seemingly, it'll re-enable the button after it gets init. It'll send init complete back to the app, which is important to keep in mind. And then when you click the button, it'll send these other messages to the app. So you can see this post message communication going on here. And then there's some other logic here that's, kind of an extension, but this is the main stuff the meat and potatoes we're looking into. Now, in our specific app that we're looking at, we have the ability to pass an arbitrary custom tab URL. So what we can do is, you might think, okay, well, let's just stick up our HTML site so that it does something, similar to this page, right? And then we can solve the flag, because in order to solve it, you just need to send a message with success in there after handling the intent. And that's true, but you do need to think about, well, what about the digital asset links that we just talked about? Well, the interesting thing about this is that they're one-way processes. So the app doesn't, have to verify that the website is correct. Even though it can, there's a way you can implement that functionality. This only works one way, where the website says, hey, here are the apps that I want to be able to do these things, like establish a post message communication. So in this case, right, there's some logic in this flag 41 activity that like looks like it's validating, but all it's really doing is saying like, oh yeah, like when we connect to, we can connect to this URL, but it's not actually saying like we can only connect to this URL. And it'll try to validate with that URL as it should, but if that URL isn't supplied, right, we don't need to validate, the app doesn't need to validate itself. We, as the owner of the website that's being passed into this intent that's opening the custom tab, because we own the website, we can just authorize the app and it'll let us pass our validation stuff. Now, again, I'm not showing super detailed stuff here because it's basically, you can copy most of what's here and get similar results. So what we're doing is we're sending our malicious link into the URL parameter that's going to get run and then opened in a custom tab. And then once the app opens our custom tab, we can, this is a little out of order. The init message actually comes first, and then we press send test message. In my code, it'll send init complete. It'll wait like 3 seconds, and then it'll send message success. And then doing so gets you the flag. Again, pretty straightforward, not that complicated. We were going to talk about trusted web activities, but there's really not a whole lot to talk to about them. They just seem like they're slightly more secure versions of custom tabs with a few less functionalities. So we're just going to move straight into talking about the kind of conclusion and what you should look out for. So if you're using WebViews in your app, if you don't need JavaScript to be enabled or a JavaScript bridge, just don't enable it. If you've got file access stuff, just, set these things here to false if you can to prevent access to local files. And if you can't, do something like that. Maybe try doing something like a content provider, or just making sure that, you're not saving stuff to internal storage and you're just saving it in the APK. Of course, the limitation there being, right, if you're saving stuff inside the APK instead of the assets folder, every time you make a change to those HTML files, you'll have to recompile. So that is something you'll have to consider. Make sure that only trusted URLs are being loaded. Again, so some of these vulnerabilities were really only a big deal because we could pass an arbitrary URL and get it opened as a WebView or a custom tab. If you have to evaluate JavaScript, make sure you're heavily sanitizing into the inputs to avoid cross-site scripting and related, injection attacks, things of that nature. As far as custom tabs go, make sure, again, only trusted URLs. You can use the custom tab session to validate the origin of the content. So that's a much better way to kind of perform that action instead of just trusting the origin. And then make sure that your, the website that's interacting with your app via a custom tab is tightly scoped in with its digital asset links. That's really all we've got to cover today. Sorry if it's a little disjointed. I'm really tired, but that's all we got for today. This will probably be the last Android video for a while, unless something else comes up. But, thanks for tuning in and listening to me ramble.